All right, we have section 2.2 day 1 today. We will be finding the slope of a line as well as doing a couple other things. We are going to spend 3 days on section 2.2 because there's just so much information in it. All right. Linear equations. A function. That word should sound familiar from yesterday. A function whose graph is a line is a linear function. A linear function can be represented by a linear equation. Hopefully that doesn't seem too shocking. A solution of a linear equation is an ordered pair that makes the equation true. You can graph a linear equation by picking values for x, the independent variable, and finding the value of y, the dependent variable. Okay, so let's graph some linear equations. We are going to start off doing this by making a table. It's not the only way to do it. It's not my favorite way to do it, but it's the first way we're going to talk about it. In order to give myself some room, I'm only going to highlight one of these problems at a time. So obviously I'll start with number 1. I will bring number 2 back after we're done with number 1. You've got extra space down at the bottom, so if you need more space to write, you can work above and below that graph. Okay, so we are going to make a table. Our table is going to have an X column and a Y column. What that last little bullet point said before is that we pick the values for X and then we find the corresponding values for Y. On a lot of problems, it doesn't really matter what you pick for X and Y. But if you see X being multiplied to a fraction, the easiest values to pick are going to be the denominator and the opposite of the denominator. So I know already by looking at this problem, I want to pick -4 as one of my options for X. I will always, unless the problem tells me not to, pick 0 as an option, regardless of the type of problem. And also the denominator itself, 4. You need to pick at least 3 values when you graph by a table for this class. You can pick more if you want to. So now that I have these X values, I have to then find the Y values that go with them, and then I'll be able to graph. How do you think I'm going to find my Y values? Plug it in. So Y equals 3/4 times -4. The reason that I picked the opposite of my denominator is because that this will multiply out nicely. If you want, you can write it as a fraction instead of as a whole, just an integer. You can write it as a fraction if that makes it easier for you. Either way, use a calculator, whatever you want to do. When you multiply those together, you should get a -3. So that means that when X is -4, Y is -3. So I will put that in my table. I go to my next one. For the next one, I decided I wanted to plug in 0 for X. Well, 0 times anything is 0. That's why I like 0. It makes the math easy. And then lastly, I said I wanted to plug in 4. So we end up with a +3. Again, if you want to work these out by hand, If you want to put them in a calculator, whatever you choose to do, as long as you were able to get the same answers that I got, that's what we're looking for. Once we have our table all filled in, we're ready to graph. So we are going to treat these x, y's as if they are ordered pairs. So I am going to graph -4, -3 as a point, which means I start at my origin, and where do I go? Left 4, down 3, put a point. Sorry, I'm trying to, there we go. Okay, and then for 0, 0, where's my point? At the origin. And for 4, 3, where's my point?
To the right 4, up 3.
Okay, right 4, up 3. You mean to where I could put a straight line through them? Yes, that is what these are. These are linear equations, which means after you have all those points, you should be using a straight edge to put a line through them. Okay. Use a straight edge. If you have some sort of magical skill where you can draw extremely straight lines, and I'm not going to know, I mean, congratulations, pat yourself on the back. But if you turn something in where it's like, sorry, I have the straight edge. If it's like this, that's not straight enough for me. Okay? I don't want squiggles. I don't want you playing connect the dots, so it shouldn't look like this. Okay? Use a straight edge. You should be able to like use the edge of your ID because you should be wearing your ID here anyway. Line it up. Make it go through the graph. Also, it should have arrows at both ends because it extends on forever and ever and ever. A final point I'll make about graphs. Haha, point, graph. No, nobody? Okay. Is that you should go through the points and keep going. So notice how my line goes like through the whole grid that I've got there. That's what yours should look like. Especially on some of them where the points are not as spread out. It shouldn't just be like a little tiny line right here. Okay, go make it go all the way through that grid. Okay, we brought back example 2. We are going to do example 2 the same way we did example 1. So that means we start with an XY table. Oops. We are going to pick our x's. This time, we don't have to be quite as careful because we don't have any fractions. So what do we want to pick for our x's?
2, 4, and 6.
2, 4, and 6. Sounds wonderful. If you picked different values, that's fine. Your graph in the end should look the same. Maybe not where your points are, but your line will look the same. Okay, we're going to adjust this and we're going to use 0, 2, and 4. If you used other numbers, that's fine. Your line in the end should look the same. You have a little bit of independence on these problems. Okay, so we're going to plug 0 in for x and solve for y. So 0 plus y equals -2. What does y come out to equal? -2. 0 plus y is just y, right? So when we plugged in 0 for x, we got y equals -2. For the next one, I'm going to plug in 2 to x. 2 plus y equals -2. Now this one's not as easy to solve. How am I going to solve this one? Subtract 2 from both sides. So y equals -4. Alright, last we're going to plug in 4 for x. So 4 plus y equals -2. We subtract 4. Y equals -6. So all of this is just like my work, right? This is not necessarily part of the answer. It's just me showing my work, which I recommend you do as well. Okay, somebody I have not heard from yet today, raise your hand and tell me how to get to the point 0, -2. Ian?
Stay in the middle, go down 2.
All right, so we don't move left or right. We're just going down 2 and putting a point. I'm going to change my color. All right, then we've got the point 2, -4, Emily. Right 2, down 4, put a point. John, what about our last one?
And then you go right 4 and then down 6.
Get right 4, down 6, which on mine up here it might be hard to see. I guess it pops up down below that icon. Even if you picked different points and your points are somewhere over here, they should still line up with the points that we made. Either way, we then grab our straight edge and we are going to make a line that goes through our graph. Mine's not great. That's a little better. Putting our arrows at either end. So there is our line for this linear equation. Standard form of a linear equation is ax plus by equals c. The easiest way to graph a linear equation in standard form is to find x and y intercepts. So make sure you get those blanks filled in on your notes. The easiest way to graph a linear equation in standard form is to find x and y intercepts. Okay, so let's talk about x and y intercepts. For the y-intercepts box, the point at which the line crosses the y-axis, that is the y-intercept. It is a point where the line crosses the y-axis. In order to find it, substitute 0 in for x and then solve for y. The x-intercept is the point at which the line crosses the x-axis. To find the x-intercept, you substitute 0 in for y and solve for x. Alright, for our examples, we are going to find the x and y intercepts and then graph. Once again, to make room, I'm going to take away b to have room to do a, and then I'll swap. It does not matter to me which intercept you find first or second. So we need to find the x-intercept, we need to find the y-intercept. I think you have a table that looks something like this. It'll catch up in a minute. There we go. So to find the x-intercept, the rule up at the top under my x-intercept box says I'm plugging 0 in for
X.
nope,
Y.
y. Under the x-intercept box it says plug 0 in for y and solve for x. So if I want to solve for the x-intercept, I can't take x out of it. I have to leave x in there. So 2x plus 4, I'm plugging 0 in for y, equals 8. I'm using this equation they gave me, this linear equation. And then I'm solving. What's 4 times 0? 2x plus 0 is 2x. So what does x equal? 4. If I were to write this as an ordered pair, as a point, what is my x coordinate? 4. That's what x equals 4. And what was my y coordinate? 0. That's what I plugged in for y. So we will treat it as if it is a point. If you want, you can go ahead and graph it. Where's it going to be? 4 to the right. It is on the x-axis. For the y-intercept, I'm plugging 0 in for x because I want to solve for y. 2 times 0. 0 plus 4y. What's 0 plus 4y? 4y. So y equals 2. On this one, what was my x coordinate?
0.
And my y coordinate?
2.
Okay, treat them as points. To graph it, where do I go?
Up to 0.
Up 2 on the y-axis. Okay, when we graph with intercepts, we only have 2 points instead of 3. We still need to make sure we've got a straight line that goes through them. Arrows on the ends. Going through our whole graph, not just connecting those 2 dots. Okay, so we're going to plug 0 in for y in order to find our x-intercept. So we have 3x minus 0 equals 6. 3x minus 0 is 3x. So x equals 2. Treating it as a point. What's my x coordinate?
2.
My y coordinate.
0.
We sound so excited about this. Alright, so 2, 0 is 2 on the x-axis. We'll move on to the y-coordinate. Or the y-intercept, sorry. The y-intercept, we plug 0 in for x. 3 times 0 minus 6y equals 6. 3 times 0. 0 minus 6y.
Negative 6y.
Beautiful. Don't drop that negative or minus sign. So y equals
Negative
-1.
1.
As an ordered pair, what is it?
0, comma, -1.
Wonderful. Always write them as points. What happens when people don't write them as points? This is why I'm making a big deal out of it. People find their x-intercept, they find their y-intercept, they graph it as a point combining them. They say, oh, x is 2, y is -1. They put a point there. They're not sure what to do, so they draw some random line going through that point. I see it every year, Algebra 1 and Algebra 2. Don't be that person. Every time you find an intercept, write that intercept as a point so that you don't confuse yourself later on. That's my helpful hint for the day. So, we're at -1 on the y-axis. Now we just have to make our line going through those points. That's better. Arrows on the ends. Slope, our last topic for today. Slope is the ratio of the vertical change to the corresponding horizontal change. Change is found using subtraction. You have more lovingly heard this referred to as rise over run. Slope can be found by taking y2 minus y1 over x2 minus x1. Assuming you're given 2 ordered pairs. So this would come if we have x1 comma y1 as an ordered pair and x2 comma y2 as another ordered pair. That's where these x's and y's come from, are 2 points. While you're writing down the examples, I'm going to put our formula up at the top. One thing I did not say on the last slide, but that we all should know, what letter do we use to represent slope?
M.
M, very good. We will start seeing that more tomorrow, I think. Okay, so I wrote the formula up here for how we calculate slope. So down here, I'm going to start it off. M equals, put a big fraction bar. In the top, I want y2 minus y1. It might help if you go through and just label your points real quick, like x1, y1, x2, y2. So that way you can just go up to those points and grab what you need. So I'm starting with y2, meaning I want the number 2, minus, what is y1?
It's a -2, but you'll change it to a positive.
It's -2, yes. In my next step, we will change that. But for now, I'm just going to plug things in without changing anything. What am I plugging in for x2?
4.
4 minus, what is, okay. Oh, you guys didn't even correct me. Thanks a lot, guys. That should have been an x1. Okay. Back down here. This was also a -2. Okay. So people were saying already, we're going to be changing this to plus. Yes, subtracting a negative is the same as adding a positive. If you don't need to write this step, or you didn't write the first step, you went straight to this one, that's fine. You do you. But I'm going to make sure I'm being careful and watching my signs. 2 plus 2 is? 4 plus 2. What do you think we want to do with that? Wonderful. What do we get? 2 over 3, 2/3. So our slope is 2/3. M equals 2/3. On letter B, M equals fraction bar. What's going in my numerator?
-6 minus 7.
-6 minus 7. Y minus y over
8 plus 2.
8 minus -2, or 8 plus 2. If I take -6 and subtract 7, where do I end up?
-13.
Wonderful. Subtracting a negative is the same as adding, so what do I get in the denominator?
10.
Can I reduce it?
No.
Nope, so that's my answer. M equals -13/10. Do not, and I repeat, do not, if you are finding slope, change this into a mixed number, into a decimal. Don't do it. Slope is a ratio. We need to write it as a ratio. A mixed number and a decimal are not ratios. So just leave it alone. I know I've said that before because I don't like mixed numbers, or I don't like decimals as much. This time, it's not just that I don't like it, it's that it would be wrong. Okay, we gotta leave these as ratios or as fractions. Okay, enough about that for now. Let's do letter C. Y2 minus y1, what is that?
7 minus 4.
X2 minus x1.
-3 plus -3 minus 3. Sorry.
Okay, so -3 minus -3, or -3 plus 3, whichever way you want to write it. 7 minus 4.
11.
Oh, we're subtracting. It's okay.
I'm so sorry.
It's all right. We're subtracting in the top. In the denominator, we do end up adding. -3 plus 3 gives me 0. Now, is this ringing any bells for anybody in here?
Yes, it is.
What sort of bells is it ringing?
That's the guy can't do the answer.
Very good. You can't do that. You cannot divide by 0.
No solution.
It's not quite no solution in this case. We say that slope is undefined.
So you kind of put down no solution. That's the same thing.
No, we say that slope is undefined. Okay, you cannot divide by 0. 0 cannot be in the bottom. Slope is undefined.